Hello and welcome to another episode of Microsoft Fabric. And in today's video, we are going to discuss some of the quick or essential functions of PySpark which you must be knowing to work on Microsoft Fabric. So I have collected some operations or functions of PySpark which one must know to work on Microsoft Fabric. So let's get ahead with that. So let me jump on to the Microsoft Fabric and the URL is app.powerbi.com. And here I'm going to open one of my workspace 01GA Fabric. In 01GA Fabric, I have already filtered out for lakes. And the lake which I plan to use is Lake 02. I can use any of the lake because I plan to bring external data today to do all this stuff. And then that data later can be saved as a table onto the Lake 02. But to run any notebook, we need a lake. So Lake 02 is the one which we are going to use for today's operations. So from here, I can go ahead and open a notebook, existing notebook or new notebook. Here to start with a new notebook, I'm going to use the existing notebook, and the notebook which I wanted to use is important PySpark commands. Click on that and click on open. I have already opened that on the next windows. Right now I'm going to press escape and I'll directly go to this important PySpark command notebook. So this is there, the lake is selected, and these are the commands and the functions or the important things which you must be knowing for PySpark's functionality. So here on the notebook, as you know, Spark notebook will get saved automatically, but you have a save as button, you have a download as, you have settings. The settings contain about, endorsement and schedule in case you want to schedule them to run. Then you have run all or run cell above, run cell below, means you can run all the cells in one go. You can run cell above and cell below, or you can go to individual cell and run. When you run it for the first time, it is going to start the Spark session. Post that, it can continue to use that Spark session. You have connect, new standard session, new high concurrency session. We will use the default one. You can set the language to PySpark, Spark Scala, Spark SQL, Spark R. For today's session, we are going to use PySpark. Everything else is workspace default, basically the environment, and data wrangling is something we have already done a video in the past. You can go ahead and explore that. Then you have add to pipeline, open in VS Code. These options are available. Also Copilot option is available, but right now I am using the trial capacity. In the past I have shown you how can you use the F64, the purchased capacity, and can enable Copilot. I have given you demo of Dataflow Gen 2, but you can also come and use it here into the notebooks. What I have done for today's video is I went to my GitHub account, and from there I have taken this file sales data for fabric.xls because it has columns that doesn't contain space. I wanted the URL, so I right clicked on the raw link, used copy link, and that is the link which I am using here in the Excel file path. Let me explain you the first set of code which I have written, and post that we will run that to load the data into our notebook. The code is import pandas as PD. I'm using pandas library to read the external file. Excel file path is nothing but the path which I got from the GitHub, the raw file path. You can see raw here. And then I'm creating df sales, and the function which I'm using here is read Excel. So we already have imported pandas as PD, and now I'm using read Excel, and Excel file path and the sheet name are the two arguments which I'm giving. In the same way, I am reading df customer, the sheet customer, df geo, the sheet geography, df item, the sheet item. In this manner, I'll get 4 pandas data frame, and those data frame, I'm going to hold the data for sales, customer, geography, and item. Later on, I'll convert all these data frame into the Spark data frame, and from there we will start our analysis. So let me run this first cell, and this first cell is also going to start our Spark session. So as you can see, there is a connecting coming on the top. It's trying to get the Spark session. We are getting a standard Spark session now. Apache Spark session read only started in 10 seconds and 998 milliseconds. So it took only 10 seconds to start the first Spark session. The Spark section has started, and we have got all the data frames. These are pandas data frame. If required, we can use function print to print the df.head, and in this case the data frame df_sales.head. This is what I wanted to print. So let's print, and it has printed the top 5 rows of the data frame sales. Now I got the data. I want to convert convert all these 4 data frames into the Spark data frame because we wanted to learn the PySpark commands which we can use on the Spark. So the process of converting this into a Spark data frame is Spark create Spark data frame and the pandas data frame. Same way Spark create data frame pandas data frame. So what we are doing, sales is coming from df sales, customer is coming from df customer, geography is coming from df geo, and item is coming from df item. Everywhere we are using one single function which is spark.create data frame, which is going to create PySpark data frame or the Spark data frame. Let me run that. In 2 seconds it has created all the data frames and time has come that we run the first command, the display command. The display command is used to display the data, and using this command we can do more operations. So first let's display and then we'll try to understand. So display command gives you this tabular view. It is right now showing you first 1000 rows, and then it provides you the tabular view, the chart view. You can download this data into CSV, JSON and XML format. Then you have inspect here. If you click on the inspect, it will load the column quality attributes and column distribution. So basically you can see missing values, unique values, invalid value and minimum to maximum distribution of the data. So order number, item ID, sales data, delivery data, customer ID, city ID. So you know what are the missing values, unique values, invalid values and the distribution of the data. Now this is based on the first 1000 rows. You can also go to the chart view and here you can create a chart. Now right now this chart is not making sense. To create a chart which makes sense, let's click on the customize chart option on the right. Now bar chart on which we want to create on this chart. Order number, no, order number is not going to make sense. We can create it on city ID or we can create it on item ID. We only have 55 items, so let's create it on item ID. What we want, series or group, let's leave that. Aggregation is sum. Values is not order number, let's take quantity. So what we are saying, create a bar chart. E is item ID, values is quantity and aggregation is sum. Do we want stacked aggregation overall results? Leave them as is now. And now you can see that we got a chart which is displaying item ID from 11 to 55 and this is showing how my quantities are summed up. You can further go ahead and create some other chart like column chart, area chart, pie chart. Pie is usually suitable when you have a smaller number of values, or pivot table. So in this manner, you can use display not only to display the data, but you can also use display to create various charts. Let's go back to the table view and move forward. So now similarly, I can display geography data. Also, if I want to analyze, I can go to the chart view and analyze this data. But right now, I will leave that. I can also display the customer data as well as the item data. So this is my customer data. My customer table also contains city and state, and what I would like to do is basically when I run the combined queries, I would not be able to use city and state because it's already available in the geography table. So I wanted to show you that I have something which is present in geography as well as customer. So we have to remove these columns from this data frame. Let's display the item table. And in item table, we have columns like brand, category, subcategory, and name. Now, I have shown you all my 4 data frames for sales, geography, customer, and item. Now, there is another command show, which can also show you the data we can also use that. So let me run that. And it's going to just show you a sample of 5 rows for each one of them. And this is how it would be displayed. It is kind of a text display, which happens using the show command. So you can use the show if you want to have a quick look at the data. Now let's come to the 2 functions which are describe and summary function. While both of the functions are going to give us statistics, there is this difference. So describe function provides basic statistical matrices for numeric columns, and the matrices are count, mean, and standard deviation, min and max. On the other hand, summary provides more comprehensive statistic. It includes count, mean, standard deviation, min, max, and additional matrices like 25%, 50%, and 75% of the median. Now, let's use these 2 functions on the sales table and try to understand what is going. And what I'm doing is I'm using the display function so that you get a better display. So you can see summary like order number, how many counts I have, mean I have, standard deviation I have, min I have, max value I have. So min value, max value, item ID, customer ID, city, quantity, price, cost, and discount. So this is the analysis of the sales table using the describe. Let's add one more and let's try to analyze the table customer. And now you can see customer ID, age, city, state, and name. And the reason I came here because we have some text column here. And you can see for the text column, it is only going to give you count. There's no mean and standard deviation for those columns. Min and max value are definitely we can get for the text column also. So this is describe what all it is going to give you. Now let's come to the summary. A summary function is going to give you additional statistics. You can see count, mean, standard deviation, min, and max. Other than that, 25%, 50% and 75%, how many values are contributing that what percentage, that also you are getting. So for order number, mean, standard deviation, how much is 75%, 50% and 75. Now same way we can also get the summaries for geography, customer and item table. So let me quickly display it for geography. So we are getting for city, ID, city and state. As usual, few items would be null because they are not applicable for text. Let's look at the summary of the customer table. Again, the customer table, we have only customer ID and age where we can get better stats. City, state and name are the text columns and the summary of item table also. Again, item ID, brand ID, subcategory ID and category ID are numeric and that's why you are getting more stats. Other are text column for which you are not getting much of the stats. Now let's move forward. What I wanted to do here is I would like to tell you about different type of joins. So to do that, what I would like to do is I would like to create two tables using only one column customer ID, and based on that, I want to showcase you what is available. I'm going to do join. So what I've done is I only taken the 100 IDs, 1 to 60 here and 40 to 100 here. First of all, let me explain you the complete code. What I'm trying to do here is, so df.1 to 60 customer.select. So I'm only needing the customer ID column. Filter customer ID between 1 to 60. So filter customer ID dot between, this can be used for the numeric one. Otherwise, we can write down the ranges also or condition also. Similarly, from 40 to 100, I'm taking again customer dot select column, the column which I'm taking, and I'm also filtering that from 40 to 100. Now, first, let me showcase you this. This got executed, and now let me display a data from it. So let me use display function so that I can get data for you. As you know, display function provides us a tabular view. Now you can see here, scroll down and I have 60. Now what I've done is inner join. So what is inner join? So inner join is matching rows. What are the matching rows here? Between 41 to 60 and 40 to 100, only between 40 to 60, only max 20 we can get. So what I'm trying to do here, inner join df is df dot customer underscore 1 to 60, the df which we have created above, dot join with the df customer 40 to 100 customer ID inner join. So when we have the ID which is same in both of them, we can use this kind of join where we can only mention the ID and the join because the column name is same across both the tables. When we move further, I'll explain you with one example what happens when your columns are not same. I have given a show function here, but I think I should change it to display. So now what happens is I have done inner join, and inner join is only matching row between the two tables. So what are the matching row between the two tables is from 40 to 60. So if you know, it is between 1 to 60 and 40 to 100. So between 40 to 60 we have matching data, and that is what it is showing. 40 to 60 is the matching data what it is showing. So we are getting 40 to 60, the 21 matching rows, because 40 is also matching and 60 is also matching, so we'll get 21. Now, what happens when we do the left join? Left join means everything with the left and plus the join rows. So whatever is not joining, those rows will come as is, but whatever is joining, if because of the join, the number of rows are increasing, it is going to get that increased number of rows. So in that case, we will get the increased number of rows, but here, because we have unique IDs, so the number of rows are not going to increase, but the first is from 1 to 60. So we should get from 1 to 60, and 40 to 60 is already matching. What we are expecting here is 1 to 60. And it is displaying the top 20 rows. It is showing the top 20 rows from here. Let's run a command to show 100. So I modified this function left.join.df.show 100, and now it should show everything. So it is showing me 60. So now we understood how the left join is going to work. So everything from the left is going to come. So left table, if the data is not joining, that is also going to come. Now we are talking about the right join. Now in the right join, the table 40 to 100, it is on the right. So what would happen? 40 to 100, everything will come. 1 to 60, the overlapping range is 40 to 60. And from 61 to 100 is non-overlapping range. and which is on the right hand side, but because this is a right join, we should be able to see this. Now again, I will use 200 so that I can get the complete display here. So I am getting data from 40, 200, and this time I performed a right join. Let's try full join. What would happen in case of full join? I have 1 to 60, 40, 200, missing from left and missing from right. And what is missing? When I do the inner join, I'll get 40 to 60. So 1 to 39 missing from the left and 60 to 100 missing from right. They will also come now. So I should get everything from 1 to 100. So let me now give 200 here. Let's see if there is more rows. A magical thing happens here. No. So customer ID 1 to 100. Everything is coming here. Now we got 1 to 100 because it is a full join. So not matching data from both left and right table is participating here. Now let's take one more example. Now anti-join. What is anti-join? Anti-join means something which is present in one table and not present in the another table. So first thing which I'm going to do here is left anti-join. What do you mean by left anti-join? Left anti-join means whatever is present in first table and not present in second table is going to come. So what is present in the first table which is not present in second table? 1 to 39. So we are expecting here 1 to 39 in left anti-join. So something which is present in first, not in second. Right anti-join is reverse of it. Something which is present in second, which is 60 to 100, not present in first. So it's giving error because we don't have right anti here. So what you have to do is you have to swap the tables and then do it. So let me do one thing. Because we don't have right anti, I'll add the code and swap the tables for you. So let me bring in this table outside, this table inside, and make it left anti, or only anti will also do, because we have only left anti that can also be called as anti. So what I've done is df.customer 40 to 100.join df.customer 1 to 60 customer ID anti. Because we have only one kind of join which is anti, there is no possibility of right anti. By default, anti is also left anti, and now we got 61 to 100. Something which is available only in the left table, not available in the right table. So what I wanted to do now is basically, I wanted to show you what happens when you bring in two tables and how does the data look like when the data is not matching. Because what happens in the last case when we were only talking about the customer ID, you were getting only one column and you were not able to understand what's happening there. So now that is why I am now bringing in sales filter, which is sales.filter sales.customer ID between 59 to 62. I've reduced it to very small range. So I'm only getting these IDs, which is 59, 60, 61 and 62, 4 IDs. And the customer table I'm getting from 50 to 60, only 10 IDs. Overlapping is 59 and 60, small overlapping. And then I'm going to perform all the joins. So first I'm going to perform the left outer join between the customer filter table and the sales filter table. Join is customer ID and it is a left join. So now you can see that I have the blanks which is coming on the right table for the non-matching data. What happens when we perform the inner join? It only gives the matching data, so there is no blanks anywhere. Right join. Now the right hand side table right now is the sales table. So we should see null. See, we are seeing the nulls here for the customer, for the IDs for which the data is available in the sales table but not available in the customer table. Let's try the full. And now we will have both kind of data which is giving null for the right table and data which is giving null for the left table. And we have only one kind of anti, so let's try anti. Something which is present in left, not in right, and left right now is customer. So this is only present in customer, not in sales. And let me do one thing. Let me copy this, put it into next, and how to write down a comment you might have already seen, but hash is the character which is going to give you command. Now let me move sales outside and customer inside. And this is something which is present in sales, not in customer, based on our filter data. I think this should have given you a good overview of what all these kind of joins are there. And you can do these kind of join in PySpark and create those data frame, and those data frame can be later written into the lake as delta Parquet files. And I've shown you that in the past how can you write down a data frame, and we'll take one example at the end of this video also, that how can you write it down. So let's move ahead. Now what we wanted to do is we wanted to merge and create one single data set for our analysis. So if you might have remember in the SQL, what we do, we perform the joins, and using those joins we combine this data. The same thing we want to do, but here there are certain duplicate columns and the customer table contains state and city, which is also present in geography. So first of all, I wanted to remove that. So let me run this function drop. So the command here is customer.drop state and city, and then I'm going to display that. So let me run this. So I'm dropping the columns. Now there is no more city and state, so they are not going to duplicate. Now what I'm doing here, already you've seen how to do joins. So sales plus customer, I'm joining the sales to the customer. On the customer ID, it's an inner join. Again, I'm joining geography. Again, inner join, we have not specified. But what I'm doing here is when I'm joining it with the item, there is a small difference between the item IDs of both the tables. So here at one place the D is also capital, another place the D is small. And I also wanted to show you how you are going to perform a join. So this is how you can give the condition and perform the join. So now you are getting a sales all table which contains sales, geography, item and customer. So all the 4 tables are there, and then we can showcase little bit of data here. So we are now combining all of them into sales all. Though I do have some couple of intermediate data frames, I have created those so that in case when you are trying to get this code, which I'm also going to put on Medium, you can play around with these intermediate data frames also. But ideally there is no need. So now we got a combined one. We could use display to have a better display of this data. First of all, see what all columns we have. So to get the list of the columns, print the column names. So sales all dot columns is going to give us all the columns, and we can go ahead and write down additional code to display the data of this combined data frame. And this is the combined data. We have everything what we need for analysis. So now what we are going to do is we are going to go ahead and analyze this data. Now, before I analyze this data, I need few calculations. I need gross sales, which is nothing but quantity multiplied by gross. I need COGS, which is quantity multiplied by cost. I need discount amount, which is quantity multiplied by price multiplied by discount percentage. So this is what I need. So what I'm doing here is I'm modifying this sales all data frame using the withColumn. withColumn will allow us to add additional column to our existing data set with the definition. So this is the name and this is the basic formula or the expression which we are using here to add this. So 3 new columns we are adding, and after that we are showing that. Let me run this. 3 new columns are added and it has been showcased here. And as you can see at the end, we are getting gross, COGS and discount also. Let's display it. Let's scroll to the right. You can see you have gross, COGS and discount columns also available. Now what I am going to do next is basically I'll tell you a few group by commands. Now how do we group the data? We are going to create a new data frame by using the existing data frame and group by. So group by, we can give the group by column and the aggregation, and in the aggregation we can give expression, and in the expressions we can give what kind of aggregation we want. Right now I'm using the sum aggregation, but you're free to change it to other aggregation as per requirement. The first example which we are going to run here is group by city and state. So I'm saying sales.all group by city and state, 2 columns, aggregation, expression. In the aggregation function, I'm giving the expression function, comma separated expression function, and in the expression function, I'm giving sum of gross as the total gross. So I'm going to get total gross column, total COGS column, and total discount column. And then finally, we are showcasing this. So let me run this. So now you got the grouped data, only 20 rows are shown, but for one of them, we are going to use display and analyze it again. You've already seen how we can analyze this. Now I want to aggregate brand and category. So sales all dot group by brand and category. Again, same kind of aggregation. But if you want, you can add one more. We have QTY column and we can call it total QTY. And let me see, I can do average. So this time I have done average for the quantity, and I got a new data frame which I'm displaying here, which contains all this data. So brand, category, total gross, total COGS, total quantity and discount. Same way, I can combine state and category coming from 2 different data frames, but they are now part of the same data frame. Again, we can display that. And finally, one small example I'm running here. I'm skipping the example of city and brand. Now you have seen enough example. You can group by. So let me run this example. And here I'm using display. And the reason I'm displaying here is because I would be able to go to the chart view and I would customize the chart. And this time what I'm going to do is I will take state. On the values, I'll take total gross. And then I can take group as category and aggregation as sum. And let me apply. I can go ahead and change this to column chart. and apply. Now you are seeing the clustered column chart. Previously you've seen clustered bar chart. But more importantly, when you go to pivot table, it's going to display rows as state, categories as columns. You can also try out line chart and other charts and word cloud. Let's see, what does it give? So this is word cloud of total gross. Let's get of state and category. Let's only get for state. California is the biggest one. So in this manner, what you can do is, so you can do a lot of analysis using Spark data frame. Also remember, we have shown you data wrangler in the past to do certain operations, and those operations you can again convert into a PySpark script and you can use it to perform those operations. So you can also try those out. Now what we need is, we need one code to save one of these as a table into the Lakehouse, and we are going to perform that operation now. So now let's try to use the save command or save function. So saves, which is a Spark data frame dot write, format is delta, and save table as and the table name. So let's try this first option. Let me run this. It can take a little bit of time, but it has done it quickly. In 5 seconds, it has saved the table. So let's refresh the table on the left hand side and see, did we get the table? Yes, we got the table sales delta. Now I want to use the other one, which is basically sales all dot write dot format dot delta dot mode overwrite. And right now I'm trying to give the relative path, which is tables slash sales all. Let's see, does it work? Otherwise we can give the full path. To get the path, what you can do is you can click here and on the 3 dots of any of the table, and then you could copy the path, and that's what we can use. If it doesn't work, then we'll give the full path and try to save it. So it's giving an error. Let's see what it's giving. Duplicate column names. So sales all contain the duplicate column names. It's not saving. So instead of sales all, let's try geography. So geography has been saved using this code. Let's refresh and check. Did we get the table? So tables, refresh, and we got the geography table. What I would like to do here is basically, I would like to go back to the lake and check out these tables. So I'm back on the lake from another tab, and let me refresh. I can see those tables. Let me click on those. I've clicked on geography and waiting for data preview. So my table is here, another table which is sales delta. Preview is loading. So now we got the data preview, the data types are correct. So in this manner, these are some of the basic PySpark functions or the commands which you can use on day-to-day basis. Do let me know what other functions and command you want me to cover in this particular series. So go ahead and try this out, and do let me know what else you want me to cover in the Microsoft Fabric series. Share this series with your colleagues and friends. Thanks for watching this particular video. Thank you.